that this pilot can control and adjust. These surfaces change the way the air flows over the wing, which in turn changes the direction and magnitude of the lift force vector. As the pilot gets ready to take off and as the plane starts moving forward, air starts flowing over the wing. But because the wing is at an angle to the ground, the air doesn't flow over the top and bottom surfaces of the wing in quite the same way. The result is that the air at the top of the wing and the air at the bottom of the wing have to travel a different distance to get to the edge of the wing. This means that the air at the top and bottom of the wing are at slightly different pressures, resulting in an upward force called lift. Once the plane starts going fast enough and the pressure difference between the top and bottom surfaces gets big enough, the lift force is big enough to lift the whole plane off the ground. The angle of the wing with respect to the oncoming airflow is very important, and it's called the angle of attack. These same principles are true for a sailboat, except as I said before, the sail is the wing. We just rotate everything 90 degrees, since an airplane wing is parallel to the ground and a sail is vertical. First, let's note where the wind is coming from, and then the direction the boat is pointing. Now I'm going to demonstrate some sailing techniques. We can confirm that the wind is indeed blowing over the sail, the same way the air flows over the airplane wing. As you can see, I just had to get enough air flowing over the sail to generate enough lift to move forward. Also notice I had to pull the sail in to get going. That's because I can control the angle of attack of the wing. If I do not adjust the sail properly, the angle of attack won't be correct. To illustrate this, let's watch what happens when I pull in the sail too tight or let it out too far. When I let the sail flap in the wind, the sail was operating at a 0-degree angle of attack. There's no lift force generated because the wind just flows directly over the sail. When I pulled in the sail too tight, the wind had a hard time flowing over the backside of the sail and created a lot of turbulence, so the lift vector was very small, so the boat was moving forward slowly. Now we can confirm that when sailors adjust the sail, they are really adjusting the angle of attack, and it's important to have the right angle of attack between the wind and the sail. Another added bonus of the centerboard is that, like the sail, it also acts as a foil. The water flowing over the centerboard also generates lift, and this lift, in addition to the lift generated by the airflow over the sail, helps the boat move forward. The boat feels the wind pushing it from behind, but it also feels the wind due to its forward motion. Because the wind vector felt by the boat due to its forward motion is in the opposite direction as the true wind, the apparent wind vector is still coming from behind the boat, but is very small. Meaning that for this wind direction, the sailor should adjust his or her sails to about here. Based on what we've learned about how sails work for other wind directions, that flow over the sail creates lift, which pushes the boat forward,